Hello everyone. In this problem, there is a family with two traits. The first trait is determined by gene H, and capital H allele is dominant over lowercase h allele. And the second trait is determined by gene T. Different genotype makes a different phenotype. So there are three phenotypes for the second trait. Two genes are located on the same autosome. And because we don't consider crossover in this problem, when two genes are located on the same chromosome, they are always inherited together. And there is a pedigree for the family with 9 individuals. And the table shows the expression of the first trait as well as the second trait. So there are 5 people with the first trait expressed, and 4 people do not express the first trait. And for the second trait, these 3 phenotypes, we need to know which genotype makes which phenotype. And individual number 3 and 6, they can make gamete with a lowercase h and capital T. And that means both the number 3 and individual 3 and individual 6, they have a chromosome with a lowercase h and capital T linked. At first, I'm going to assume that the first trait is dominant because more people have the first trait expressed. That means individual number 1 and 6, they have capital H allele because they have the first trait. And that means individual number 8, 5, and 9, because they don't have the first trait, they are homozygous recessive for the gene H. So they have only lowercase h allele. So number 9 should have the chromosome with lowercase h and capital T coming from his father. And that means because 9 is homozygous recessive for gene H, his mother should have one lowercase h allele. And because number 9 has at least one capital T allele, the third phenotype for the second trait should have one capital T allele. And individual number 6 also has one capital T allele, so that means the first trait for the second trait, first phenotype for the second trait should have one capital T allele. That means the second phenotype for the second trait is made by homozygous recessive T allele. No. In this case, we are just saying two lowercase T allele. For the second trait, we don't say which one is dominant or which one is recessive. So that means individual number 1 should have two lowercase t allele, and individual number 5 should have two lowercase t allele. And if we compare the first phenotype and the third phenotype, because it is more likely that heterozygous, there are more heterozygous people than homozygous people. I'm going to assume that the first phenotype is made by this heterozygote, and the third phenotype is made of two capital T allele. So individual number 9 has two capital T allele, and number 8 and 6, they are heterozygous for T allele. And number 6 has this chromosome with a lowercase h and capital T allele. That should come from individual number 2. Because he receives the other chromosome from his father. And number 2, individual number 2 should have one lowercase t allele for her daughter. Because individual number 5 have a chromosome with both lowercase h and t allele. Individual number 1 and 2 should have those chromosomes. That means B is individual number 2. No first trait and heterozygous for the second trait. And for the remaining 3 people, 3, 4, and 7, they all have the first trait expressed. And that means they should have at least one capital H allele. And individual number 8, the chromosome with lowercase h and capital T allele, the chromosome come from his father, so that means individual number 4 should have the chromosome with lowercase h and lowercase t allele. And individual number 7 should have the chromosome with lowercase h and capital T allele for number 9. That means only individual number 4 can be homozygous for the lowercase t allele. So that means C goes to individual number 4. And for number 7, the chromosome with a lowercase h and capital T allele come from her father, so she receives a chromosome with capital H allele and lowercase t allele from her mother. That means number 7 goes to A. So individual number 3 is homozygous for capital T allele. So D goes to number 3. So with these genotypes, first statement is true. A is individual number 7. And the second statement, the first phenotype is determined by heterozygous, the capital T and lowercase t allele. So the second statement is false. And for the brother of individual number 9, if individual number 6 and 7 make another child, we can make this Punnett square. So there are 4 possible cases. And we want to find the probability for the phenotype same as individual number 3. Individual number 3 has the first trait So that's 3. But individual number 3 is homozygous for the second trait with 2 capital T allele. But capital T allele goes to this case, so it's not possible for the child to have the same phenotype with individual number 3 for the first and the second trait, and they are separated, so the probability is 0. So only the first statement is true. And that's it for this video, and thanks for watching.